just eliminate like some unfold talk. So we said about this. Mainly is Berlin or Panzer? Very close to the airport. I think it's yeah, this is so, yeah, there is a yes, yeah, psychology is on the outskirts. Yeah. And I think it's fairly far. I mean, we were staying in the city center this time, and we were getting closer to his office when we were at the airport. Yeah, that sucks. Because basically the campus in the center is the only part of it. That's not really my idea. Not necessarily, it's not for me to make a universe. So there's nobody in my immediate surroundings. So let's say, yeah, let's go to probably still too much about no, this is just a context of my surroundings. So you see all that in the conference?
Okay, so let's start. Welcome everyone. I'm very happy to present Dirk Wulff, that is here to present his work on using embeddings to automate jingle-jangle detection type of taxonomic incommensurability. And Dirk got his PhD in Basel, and now is working at the Planck Institute for Human Development and he has worked on quite many different topics, also putting them together, putting together research line that sometimes they are not, they don't go well together, but they are not together. Decision making is perception, language, of course, semantic networks, stuff, aging also. And to be honestly, he is here because when I saw that he has this paper that trying to do something about taxonomic incommensurability, as a skeptic when it comes to anything taxonomy related, it is very interesting, very important. So, welcome, Dirk, and let's see you.
Hi, thank you, Marco, for the introduction. Thank you for having me. It's my pleasure to tell you a little bit about my work, particularly about this project, which has been one of my favorites over the last year or two. It's not really sort of my typical area. I mean, Marco already said that I tend to dabble in different things. Up to this point, I've never dabbled in personality psychology. So this is really sort of a perspective from the outside in, using something, however, that has really become sort of a staple in my work over the last few years, and that is language models. And try to see whether we can use language models to maybe clean up a little bit in personality psychology and try to consolidate the conceptual space. And we don't do this in personality psychology because we think personality psychology is particularly in need of a cleanup, right? We do this because it's particularly easy to do it there with language models. But in fact, I believe the cleanup is necessary in large parts of psychology. And I believe that also, at least with some adaptations, this pipeline that we've developed for personality psychology may apply there as well, to help us perform conceptual consolidation more broadly in the psychological sciences. So The basic problem that we try to address is one that has been known in the sciences for quite some time. In fact, Thomas Kuhn, the important historian and philosopher of science, already identified this and called it taxonomic incommensurability. Taxonomic incommensurability refers to taxonomic systems. So this is the words and the concepts that we use to sort of refer to the things that we study, right? And incommensurability refers to the fact that they don't match, they don't go well together, such that cumulative science becomes difficult, right? So this is a situation where one group of researchers is using some terms, another group of researchers is using other terms. These terms are somehow related, but still are not the same taxonomic system, and then it becomes really difficult to really sort of integrate the findings and produce a truly cumulative sort of scientific agenda, which maybe you share the impression is a situation that is unfortunately all too frequent in the psychological sciences, that there's always another lab using maybe studying similar things, but just decides to use a different terminology, different models, different theories, etc. And that's a problem because we can't integrate our findings. Personality psychology is, I believe, a case where taxonomic incommensurability is present. And here's one way of showing this. What you see here in relatively small font are the 460 or so measures that you can find in the International Personality Item Pool. The International Personality Item Pool is a database of personality scales and measures and the corresponding items that's publicly available, right? And includes several thousand items that, if you aggregate them, they are supposed to measure these 460 or so constructs. And what you see here written are the labels that are given to these scales or measures, right? They're ordered alphabetically, and you may be able to see that some of them are written in bold, and these are labels that occur more than once across these 460 ones, right? So you can see that there's like 6 different assertiveness scales. There's 8 different gregariousness scales, right? There is a lot of scales on orderliness or perfectionism, etc., right? So there's a lot of scales that are supposed to measure the same constructs, at least based on the name that was given to that scale, right? Now the question is, do they actually measure the same thing, right? In most cases, they have different items, right? Otherwise, they wouldn't be included as different scales. So do 2 sets of personality items, given the same name, actually measure the same thing, right? That's one problem. The other problem is that it could also be that you have 2 scales that are given different names, but actually have a lot of the same items and may overall measure the same thing. And these 2 problems, they have been given names. And these names have also been around for decades. They're just not so frequently used. And these are the names of jingle fallacies and jangle fallacies. Have you heard of these terms? Can I get a show of hands who has heard of jingle and jangle fallacies? All right, yeah, not so much. So these terms have been around for quite some time, and are in recent years gaining popularity again in the context of many other people realizing that we may need a conceptual cleanup in the psychological sciences. So jingle fallacies are situations where you have one construct but different measures. So this could be a situation where you have 2 scales belonging to or assigned the construct orderliness, right? But actually may be different. Right? So here it's reflected in 2 items, right? One scale for orderliness, for instance, has the item do unexpected things, and another scale has the item can never find anything, right? Both of these scales are supposed to measure orderliness, but based on an intuitive reading of these items, right, they really tap into different things. Both may be deserving, because language is fuzzy, of the norm orderliness, but they're still not the same thing, right? In one case, it's about sort of doing an unusual thing, being maybe not very traditional, creative, etc. In the other case, it's just being tidy. So these are jingle fallacies. And then on the other hand, you have jangle fallacies where you have one measure that is assigned to different constructs, right? which is also a problem because then you might wonder, is it measuring one or the other? Maybe it's not even measuring any of those, right? Yes, so taxonomic incommensurability is a problem. There's clear evidence based just on the wealth of different instruments and measures and constructs that personality psychology has been developing, that taxonomic incommensurability is a problem in personality psychology. And what I will try to do in this talk is to try to address this problem from the perspective of jingle and jangle fallacies and find a way to maybe detect them and later on also try to get rid of them. And how do I want to achieve this? Using embedding models. Embedding models are models that are able to take in text and produce numerical representations. Embedding models have been around for quite some time, and there were cognitive scientists back in the 70s working on this, producing a method called latent semantic analysis that you may have heard of. There's also methods like Word2Vec or Glovey, etc. But these days, when we think about embedding models, we primarily think about large language models, right? So we can think of the ChatGPTs, or maybe, and this we will primarily look at here, although we also have other models that are from OpenAI that we've evaluated, sort of the previous generation models, BERT models. So the first generation of transformer models that have been found to be actually really good at producing numerical representations of the meaning of text, such that we can use them then to do all sorts of downstream tasks with them. So, so we're dealing with transformer models here. I won't go into the detail of explaining exactly what a transformer model is. It's really not the place, and also I don't think we really need it. Nevertheless, I do want to give a little bit of intuition of how this works. So these transformer models, they are neural network models. They're very complex. That's why these days they are depicted with these different components that are sort of placed in sequence of one another that then transform the inputs of the model in different ways. And during training of these models, what these models are doing is that they take some text as input, and then these models will try to predict a token. And a token is a word, it can be punctuation, it can be a subword, etc. Right? So predict a token that it is in the place of one token that was previously selected as one that the model needs to predict. For the kinds of models that we deal with, this is typically some kind of token somewhere in the middle of the text, which is called masked language learning. So we mask some tokens within the text, then we give that text to the language model, and we ask the language model to predict whatever tokens likely are in place where we put these masked tokens. There's another way of doing this, which is called causal language modeling, where we always try to predict the next token, which is a really good mode of training models to produce text. It's not strictly the best way to produce models that are good at producing embeddings or numerical representations. So these models are trained with a lot of pieces of text where we mask some tokens and then we ask it to predict the token, and then they get feedback from that, right? And that feedback is used to change all of the parameters within these models, which can be a few hundred millions up to a few dozen billion parameters. Or obviously in the models that we don't have access to, also potentially a few trillion parameters. And what happens in all of that training, and we really train these models with ridiculous amounts of text. We're talking pretty much all of the internet, or a curated form of all of the internet, is that the model figures out a numerical representation within its layers that helps the model to predict, based on the input, what the right token is. And it happens that those numerical representations that are used to predict the missing tokens, they're also really good numerical representation to just represent the meaning of the input. And so what we will do here is that after these models have been pre-trained, that we just feed in a piece of text that we're interested in, say open source LLMs rock, or a personality items like I like to go to parties. We feed that into the transformer model, and then instead of having it to predict tokens, we just extract at the very end the numerical representation that it has learned to produce. And then we take that as the basis to analyze these texts that we fed into the model. Later on, I will tell you exactly what model we use. So we use a lot of off-the-shelf models, so a lot of available pre-trained models. I don't know if some of you have already experience with language models. There's a fantastic open access and open source space where with thousands of models that you have access to that have been pre-trained using really significant resources, and they're just freely available for you to use. So we use some of those, but the main results will be based on a model that we, on top of the pre-training that the model already had, was fine-tuned with personality data so that the model is even better able at predicting the things that we care about. Okay, so we have a model that spits out numerical representations of text, and these representations reflect the meaning of the text in a really accurate way, which has been demonstrated in all sorts of parts of psychology, that these vectors are really good. And that means we can take them also to maybe represent personality items. So the first step in our analysis is that we take all of these 4,500 items and one by one feed through a pre-trained language model, and then we extract these numerical representations. In this case, for instance, this is from a BERT model, so one of the sort of last generation language models. These hidden representations are 768 dimensions long. So for every piece of text, we get numerical vectors with 768 numbers. Right? And then we can do it for all of these items, and then we can stack them on top of each other. And that gives us then this embedding matrix that you see here illustrated on the left-hand side. Right? So what this is now is basically a semantic representation of all of the different items, then being placed in a semantic space that has 768 dimensions. And each of these items now has a location, and the location tells us about how similar or different each of these different items are. And this means, so the distances tell us, and the way we typically quantify distances in working with these embeddings is using cosine, in particular cosine similarity. So we look at it as sort of similarities rather than distances. Cosine similarity is very similar to Pearson correlation, right? It's just a Pearson correlation, but you don't centralize the variables. Then that's what we do here. So it's very similar to Pearson correlation. Cosine also varies from -1 to +1, indicating sort of a strong negative or strong positive relationship. It's rare that you get the way this is set up, strong negative, but you typically have everything from really unrelated to really highly related. Yeah, and this is already really useful. We won't be working so much with this matrix, but this matrix could be the basis now for all sorts of interesting analyses. And we use it also a little bit for some validations. So later on, for instance, we'll ask, can we predict the internal consistency of personality scales, right? And the way we look at this is that we look at the average similarity of items belonging to a scale, right? And we use this as a proxy for the average correlation, right, of items, and then we can use this to predict what the internal consistency of that scale is supposed to be. We could also use this now to construct new scales, which is not something we'll do, but I'll briefly talk about at the end, which I think is something that these methodologies are really useful for as well, just constructing new scales based on the item-by-item correlations. What we will work more with is the measures, so the scales. So we mostly work with aggregates of these item embeddings. So in order to produce an embedding for each scale, we just take the embeddings for, say, the 10 items within that scale, and we just average them. And then the average is the representation of that entire measure. And then we can do, again, similarity, and now suddenly we have a similarity space for all of the different scales within the international personality item pool, right? Which is very useful to now ask questions like, is it true that all scales that have the label orderliness, that they're all actually very similar, or there may be some that are different from the other scales measuring orderliness, right? So this is what we would get from looking at that matrix. What we can also do, and this is something that we thought was really cool, because it directly leads to then sort of opportunities for identifying Jingle-Jangle fallacies, but also later on trying to reconsolidate the space, is that because this is a general semantic tool, we can not only embed the items, we can also embed the constructs, right? So we can take the word orderliness and feed it into the model, or we can say the personality construct orderliness, or we can take the definition of the construct of orderliness according to the APA dictionary, right? And feed those into the semantic space, and then we can directly compare them to the items that we use in order to measure these constructs, right? So what you see at the bottom is that we have here in total 277 different labels within IPIC. We can embed them and then also do a similarity matrix, and then we know how similar is orderliness to organization, how similar is gregariousness to sociability, etc. And finally, which is most crucial in the end for trying to clean this up, right, we can really directly relate them to one another. So we can take the representation of the scale orderliness based on its item and the representation of the scale orderliness based on its label, and ask how similar are they, right? And ideally, they are very similar, right? And ideally, for every scale, there's no other label that is more similar to it than the label that has been assigned to it. And that's what we can do use later in order to clean this up. Yes, please.
Just a clarification. So when you use the word label, it's not just a label, it's a long description of the construct. Okay.
So I say a bit more later about this. We actually try different ways. So we use the individual word, we use the contextualized word, we use the APA dictionary, and we also we try to use ChatGPT to generate all sorts of definitions, which actually were better than the ones that we have in the APA dictionary. They're really bad, which is, I think adding to the evidence that we already have that we're really bad at sort of doing house sort of keeping on our conceptual space, right? Yeah, but in fact, we found that with the fine-tuned model, that the individual words were actually the best. And I'll tell you later how we decided this. All right, so we have these embedding models. We can use them to embed items. We can average the embeddings of items to get the embeddings for scales. We can also use these embedding models to embed these construct labels, and then we can compare them to the scales, which now allows us to do all sorts of things. But first, before we use it, obviously we want to make sure that they're accurate, right? Because I mean, they just spit out numbers no matter what, right? We need to know whether the numbers these embedding models spit out, that they're actually useful for predicting the stuff that we care about in personality psychology. So in the next few slides, I'll go through a few validation steps that we took in order to make sure that these models are actually really good at capturing the things we care about. And first, let me tell you about the model that we use. So, sorry. So in the end, after some other lab decided to publish or have a preprint on a model that was fine-tuned, we decided also to fine-tune the model. We were a bit reluctant in the beginning because fine-tuning a language model always has the risk that you fine-tune it for just the things you care about at hand, right? And thereby make the model worse maybe for some other stuff that you didn't have data available, right? So we were a bit reluctant in the end. We went there and we found that it actually works well. So what did we do? We got the open data from a number of different personality inventories. This is this open psychometrics project, I think, and then that sort of is a bit of a citizen science project where people on the web just fill out personality questionnaires in really large numbers. And then we also use the Springfield community sample, which is a large personality project from a couple of decades ago, which had like a sample of 1,000 people who filled out, I think, 20 different personality inventories. So we grabbed the data from those cases and computed the correlations between the items, right? And we did, we have 5 distinct inventories. So we have the data for the Big 5 inventory, for the Hexaco, the NEO, the 16PF, and the FFM, right? Which you can see is a really very core personality inventories, which I think now speaks to the sort of the problem that we anticipated, that maybe we build a model now for core personality that isn't so good and on more fringe personality theories. Nevertheless, this is what we took. We computed all of the empirical correlations, and the numbers that you see here are the amount of correlations we extracted from these databases, and then at the end, we got another sort of 110,000 correlations from the Springfield community sample for a total of 200,000 correlations on the item level. And what we did then is that we fed the model with a pair of items, or it's basically 2 models, but they have to use the same parameters. We fed these models with a pair of items. They produce these embeddings at the end, and then at the end, the cosine similarity is calculated for these 2 embeddings. That gives us a prediction for the correlation of the items, and that's what we compare it to and then produce a loss, right? And then we do it for all of these 200,000 pairs, and for every single pair, the model has a chance, or it's batch, so I think it's only for every 60, after every 60 pair, the model has a chance then to update its parameters to improve the prediction for the next batch. All right, and that worked really well. I'll show you in a second what the performance looks like in sample, which is ridiculous, but also we'll see that out of sample, the performance is really good. The model that we trained is publicly available. So I don't know if some of you have experience with Hugging Face. Anyone? Okay, 1 or 2. Yeah. So Hugging Face is a massive player now in the language model space. They're a bit like maybe we can think of it like the GitHub of language models a little bit. So what they do is they offer a massive space for you to upload your language models, and all of the big players do it. So Meta is uploading their models there, Google is uploading their models there, etc. But also there's all sorts of smaller models. So we used, I didn't say this, we used this MPNet model, which is sort of is a bird type model that is relatively small. So we used it from Hugging Face, we fine-tuned it, and then Hugging Face makes it also really easy to upload the model again to the Hugging Face hub. And now you can use it, right? You can download it to your machine and use it there. You can also play around with it. So there's a little inference API there. You can type in some sentences there and see what it predicts. Hugging Face also provides Python libraries that makes it very easy to use these models locally on your machine as well. So it's really good. And if you, sorry, this is the advertisement section of the talk. If you need guidance on how to use these models, we recently wrote a tutorial. This is with Marcel, who I think was a speaker here a couple of weeks ago, or last couple of weeks ago. Yeah. Rui Mata, and also my doctoral student, Zach Hussain, who has been spearheading this mostly. Yeah, and in here, also the first practical example is is inspired by this project. So the example goes through embedding personality items, evaluating the correlation, well, they match the top level factor, etc. All right, enough with the advertisement. Let's look at some validations. So the first thing we did is try to predict the internal consistency of scales. What you see here on the y-axis is the internal consistency that we got from IPEP. And what you see on the x-axis is the one that we generated from the similarities between the items based on the language model. And you can see it works kind of okay, right? So in sample, so this is when the model actually had access to the items, then we have a correlation of 0.75. Out of sample, it's lower, of course, but not by much. We still have a correlation of 0.61, which is higher. And this will be true for all validations for what we got from the best available off-the-shelf model. So overall, the best off-the-shelf model that we, for this data, we found was the latest OpenAI embedding model. So OpenAI not only does ChatGPT, they also do embedding models that you can access through the API. And that one we found to be best off the shelf, but it's for this one, I think it was close, but for some other ones, it's really, it can't compete with the fine-tuned model. Then we also evaluated what we call structural fidelity. So here we looked into the data inventory by inventory, and we asked for an inventory, are the items closest to the other items from the same scale relative to the item similarity to items from other scales? And we calculated, or we quantified this using a z-score. So we took the similarity within a scale relative to sort of the cross-scale similarities. And what you can see is that all of the z-scores, they're relatively high. Arbitrarily, we set the recovery threshold at 2, that when sort of the within scale similarity had a z-score of 2 relative to everything else, right? Then we said it's recovered. And for most of the scales, that was true. Here on the right-hand side, you also see that these structural fidelity scores that we obtained, they're really spot on with what you see empirically. So these little sort of open squares, they are calculated based on empirical data from these inventories, right? So you see there, the structural fidelity is also not perfect. And you see that the predictions of the model are really exactly where the structural fidelity is based on empirical data are looking, right? So it really mimics the character of empirical data well. Maybe most important is this evaluation here, because here we're asking how well can we actually now predict these the correlations between the items. And it's quantified here both in mean squared error, mean absolute error on the top, and Pearson correlation at the bottom. And here are also, you see a reference line for the OpenAI model. And blue is in sample, so this is when the model has seen it, and yellow is out of sample. And if we start maybe with the Pearson correlations at the bottom, here you see that in sample, really the correlations between, it's a bit abstract, but the correlations between the predicted cosine values and the empirical correlations, they're near perfect. So we're always sort of up above 0.9. The FFM and the big 5 was a little bit lower, but we have like on average over 0.5 correlations. Right? If you look at it out of sample, it's a little bit reduced, but it's still pretty good, right? You still see that we get sort of item-wise correlations of on average about 0.7. So overall, we explain about half of the variance of these item by item correlations in empirical data. It's pretty good. It's not as good as it could be, of course, right? Because of the reliabilities aren't terrible, although for the item level, they're also, I guess they are not as high as they are for the scale level, but still, so we explain a significant amount of the variance. And up there, you also see it sort of in the scale. So in sample, you see we are on average about 0.06 off, and in sample and out of sample about 0.1. Which is also, it's not fantastically small, right? So this means that the true correlation is 0.2. The model might predict 0.1 or 0.3, roughly, right? But But overall, right, remember, we're not doing this at the item level in the end, we aggregate at the scale level. This provides significant signals for us that we can work with to perform the analyses that we want to perform. Here's another visualization at the level of scales. So what you see here on the left-hand side is the scale level correlations for the NEO. The NEO 300, so that one has 30 subscales. So you see a grid of 30 by 30. Then on the right, you see the prediction in sample and prediction out of sample. And you can really see how the important patterns of that heat map on the left are picked up by the models. Right, so overall, we can explain a significant amount of the empirical patterns and personality, which is great because then we can use it for stuff. It's also really interesting from a theoretical level. That's something I'm very keen on maybe going into in the discussion. So what does it actually mean that we can do this, right? What does it reveal about the nature of personality judgments, right? Are there maybe strong semantic components, not only in this exercise, but when humans produce these judgments in the first place? All right, and finally, we looked at the scale label alignment. So with labels, the tricky bit is that we don't have any empirical data to go off, right? There are no correlations for labels available. Obviously, we could try to ask experts, but they probably won't agree in ratings of the similarity of labels. So in lack of having an empirical basis that we can use to validate this approach, we asked whether the labels are aligned based on the current mapping, right? So the mapping that we have in IPIP, the mapping between labels and the corresponding scales, that we have in IPIP or in personality psychology in general is on average pretty okay, right? I mean, if you take a scale for orderliness, then probably, or it's unlikely that somebody named that scale neuroticism, right? Probably they named it orderliness or organization or conscientiousness, right? So three things that are very similar, right? So we can take the similarity between the scales and the labels as a way to maybe figure out what's the best way to represent the labels. And what you see here is this alignment, again in the z-score. So we ask, how similar is the label to the corresponding scales relative to other labels to the same scale? And here I only show you two different ways, because the figure in the paper you'll see is a lot longer. There's also evaluations for GPT-based definitions. We decided to not use them, although they were really good. GPT is really good at producing definitions for personality constructs. Here I'll only show you the evaluation for the API definition. So we went to the API dictionary, and scraped all of the definitions. We also tried to curate them a little bit because we realized some of them are actually really bad. And we pitted this against just using the labels as they are, or sort of using contextualized labels where instead of just using the label, we say the personality construct, colon, and then the label. And that didn't really make much difference, and the APA definitions were bad, so at least for the fine-tuned models, we found that just using the label actually works really well in terms of the scale label alignment. And you also see that the alignment is pretty high. So there is really a strong signal there that, right? So this tells us that we can actually fairly accurately not only evaluate these items and scales, we can also fairly accurately evaluate the labels. All right. And now with this, knowing that in all sorts of different ways, these models capture a significant amount of the variance of empirical patterns, we can now use them for the things that we wanted to use them for, and that is to start with a cleanup of the conceptual landscape. And the first step of the cleanup is that we wanted to use this to identify jingle-jangle fallacies. The second step will be to try to relabel scales so that we minimize Jingle-Jangle fallacies. So the way we went about identifying Jingle-Jangle fallacies is by looking at the label and the scale similarities. And we argued that, I mean, based on this definition, right, that a jingle fallacy should be one where the label similarity is really high, right? Maybe even identical labels, but we didn't just want to consider identical labels, but also extremely highly similar labels like organization and orderliness, right? So for jingle fallacy, that should be really high, and then on the other side, the similarity of the scale should be really low, right? And for jangle fallacies, the other way around, right? So the label should be really dissimilar, but the scale similarity should actually be really high. Now, the problem is, and this is something we realized after we submitted it, we got reviews, is that it's not actually so trivial to set these thresholds, right? At which point are two labels identical, right? Or so identical that you can speak of a jingle fallacy, right? And at which point can you say they're really different, right? So initially we didn't really have a good idea, but fortunately the reviewers didn't like the arbitrary thresholds that we set, forcing us to think a little bit about what would be good ways of coming up with these thresholds. And then we came up with this idea here, which is not providing us with sort of super accurate thresholds, but still I think provides sort of a useful way to think about thresholds. And it's coming off sort of an idea of how many different things we expect there to be in personality psychology in the first place, right? Based on all of the big five work, we know that, like most people would agree, that there are at least 5 different things in personality psychology, 5 different sort of tendencies, 5 different constructs, right? And if that's true, if there are 5 different things, then we know that 4/5 of pairwise relationships belong to different things, right? So this gives us a quantile in the similarity distribution that we can use to say, then these things must be different because there can only be 1/5 of things that are the same. And on the upper end, and this one obviously is a bit more arbitrary, but we had about 277 different construct labels, and we figured probably less than that because otherwise we wouldn't have a problem, right? So we figured, okay, maybe there's just 100 things there. And if that's true, then we know that 99 out of 100 of relationships belong to different things, right? So this again gives us a quantile that we can use in order to identify sameness, right? So 4/5, the quantile of 4/5 gives us a threshold for differentness, and the quantile of 99/100 gives us a quantile for sameness. And with this equipped, we can do Jingle-Jangle detection, right? So we basically introduce cutoffs, right? And then we can figure out, are there cases where maybe then in label similarity, they're above the cutoff, and scale similarity, they're below the cutoff, right? And that will be a jingle fallacy and the other way around, right? And here we get 340 jingle fallacies and 164 jangle fallacies, out of a total of 100,000 pairs, right? And I don't believe that these are really the only fallacies in there, right? Or that necessarily all of these fallacies that we identified are fallacies, right? This is on the one hand because these methods are not perfectly accurate, right? So we're not explaining 100% of the variance of empirical data, so therefore there's some error in there, right? And on the other hand, still our thresholds are arbitrary. And if we set more liberal thresholds, then we would also get a lot more fallacies. Yet, I mean, I'll show you some examples in a little bit. This tends to work okay. But before we go there, let me just give you an idea of how much this varies by the different sort of thresholds that you set. So here we have on the x-axis the minimum number of constructs, and on the y-axis the maximum number of constructs for some range, right? We could even extend that range. And what you see in the cells is the number of fallacies that you get, right? And you can see that jingle fallacies could go from 0 to almost 2,000, right? And there's even, there's also a significant spread among the Jangle fallacies, right? So this really depends on where you set these thresholds. And this is something I believe if we want to continue sort of taking this approach, we probably need to think about. But I think it's something that I think will be generally useful to think about, or to also arrive at a consensus of what is actually a good conceptual space, right? Do we want one that has 1,000 different constructs, right? And maybe we do, because then, provided we would actually have the right kind of scales for every construct, then we have a lot of nuance available to describe stuff, right? On the other hand, if it's 1,000 different things, and we know that the mapping of the scales to the labels isn't perfect, right? Then that obviously is a lot more messy than if we only had, say, 100 things, right? So I think this is something where a field needs to come together and think about what is actually a useful conceptual space for all of the different purposes that a field has in scientific progress as well as application in the world. Anyway, here's a few examples. So I talked about orderliness a lot. This is because there's also a lot of fallacies concerning orderliness. So this is an example of a jingle fallacies. We have the orderliness in the HPI-HIC and orderliness in the 6FPQ. And you see here on the left-hand side, right, is a lot about sort of doing silly things, not liking routine, etc., right? So like a little bit going against tradition. And on the right-hand side, you have the cliche, like, I like to keep my room tidy, right? So very different meanings, but assigned the same construct label. Here, the same thing, just with two very similar constructs, right? We have orderliness and organization. They're extremely similar, but the corresponding content of the scales is different in the same way that these other twos have been different. So still sort of not liking routine, liking to keep the room tidy. Then here's an example of a Jangle fallacy with items highlighted in bold that are shared between these scales. And this is something that I only learned through actually working with this data, that sharing items is massively common within that space, right? Which obviously when then scales that have a lot of shared items but don't have the same scale is obviously a recipe for a Jangle fallacies, right? So here you see that a large fraction of the items are shared between them. But the two labels, they're not so similar, right? Obviously, you may be able to construct some kind of similarity between organization and conscientiousness, but it's really not exactly the same thing, right? And also in language, these are fairly different. So this will be identified as a Jangle fallacy. And there's also Jangle fallacies that, although they're a minority, that exist even though there are no shared items between the scales. So this is one of these examples with a scale called forcefulness and a scale called happiness. And they're basically, they capture a very similar thing about sort of being comfortable with oneself or easily being embarrassed, etc. Right? But obviously happiness and forcefulness is not exactly the same thing. All right, so yeah, these are some of the fallacies we identified. Again, we do not at all claim that these are true fallacies necessarily, or necessarily the only fallacies, but they're good candidates that we can now use to direct research efforts or to inform consensus efforts to try to consolidate this space. And the next analysis is in a similar spirit. So the other thing we try to do is now try to come up with a way to consolidate this space. And here also, we don't want to argue that this is necessarily producing the right space, in the end. But it gives us a candidate that we can work off of. And it also shows us that it is possible. Right? It is possible, I will show you, to have a more parsimonious space using fewer constructs that is committing fewer fallacies. And at the start of this, I want to go here, which is one of the other insights that we had about this, that I don't think we were thinking clearly about in the beginning. In the beginning, we thought we just fix the mapping of things and then all of the fallacies go away. Right? And it is possible. If you have really the perfect vocabulary for construct labels, it is possible. And you allow for a large construct sort of clusters. But if you don't have the perfect vocabulary and you want to deal with a finite construct space, then you always run into what we label the jingle-jangle trade-off. So it is common, and you'll see this in our optimization attempts, that when you try to eliminate one type of fallacy, you may create another type. Right? And this figure tries to provide an intuition. Here on the left-hand side, we have one construct with a lot of different sort of construct label, with a lot of different scales under it. Right? But you see they span quite a bit of space, right? Which you should read as there's some scales there that are more different, some are more similar, some are more different from one another, right? Including some that really have a maximal distance within that space, right? So this would be now a candidate for a jingle fallacy, right? Same label, but actually this pair of scales is quite different in content. So how do we fix this? We fix it by breaking up that cluster, right? We just take one part of these scales and put it under one label and another part put it onto another label. And then we get to the situation on the right-hand side. And here you see that we fixed that jingle fallacy, but potentially we may have created a jangle fallacy because we now have pairs of scales under different labels that are extremely similar, right? And here we need to have the right kind of vocabulary to assign to these clusters so that they don't become a jangle fallacy. So it's not so trivial to optimize both at the same time. So how do we go about relabeling? We decided for a two-step procedure. The first step in this procedure is that we produced all sorts of clustering. So took a clustering algorithm. In fact, we tried multiple different ones. I think in the end, I'll show you the result for, if I remember correctly, for hierarchical clustering using a Ward-D linkage criterion, which is like a variance minimization criterion. And we produced all sorts of clusters. So we started with a number of clusters 2 up to a number of clusters 277, right? So these are all sorts of ways to parcellate all of the different scales into different groups, right? But they lack a name, right? This is just the clusters. And then in the second step, for every clustering, we used a bipartite graph matching algorithm to then assign the labels to these clusters with maximum similarity. So you specify in these methods an overall loss, and the method tries to minimize the overall distance in similarity or maximize the overall cosine. Right? It's exact same scale label alignment that I showed you earlier. Try to maximize that in assigning new labels to all of the different clusters. And we had the constraint that every label could only be used once. And that gave us this, right? So here now you see on the x-axis the number of different clusters. And on the y-axis you see now the number of fallacies. This is how we in the end evaluated whether a relabeling solution was a good one or a bad one. And you see that as you increase the number of clusters, jingle fallacies go down, right? Because you break up these larger clusters and give them different names. But you also see, at least, but to a smaller extent, that jangle fallacies tend to go up, right? So based on the current vocabulary, it's not possible to minimize both of them at the same time. What you also see is that a lot of the work is done in the beginning, right? And then there are only small improvements, which means that we have optimal solutions there at the very end with like 220 roughly clusters. But we also have a parsimonious solution there with, I think it's like 80 clusters, right? That commits almost as few fallacies as the optimal solution, and importantly, commits fewer fallacies than the original mapping, and that's displayed here with the horizontal dashed line, right? So we can use like 1/3 of the labels, right? And commit only, you'll see half of the fallacies of the original solution. It's half because this is on a log scale on the y-axis, so it's a bit deceiving. Yeah, and in the end, we try to display our solution like this. This is it's a little bit difficult to go through now in this presentation. But yeah, this radial plot here in the center shows all of the different constructs that were chosen by the relabeling algorithm. This is the parsimonious solution, which has 68 different clusters and labels. And then on the outside, you see all of the 459 different scales within IPA. Right, so this one has much fewer clusters and also much fewer fallacies than the original setting. Yeah, this is available as a preprint, and hopefully will also be accepted sometime in the next month or two. Yeah, and there's a few interesting things that comes out of this. I mean, one is really a conceptual question. It's like, why does it work? Why can we use language models to predict the relationships between personality items so well? What does it reveal about the processes of generating these judgments? Yeah, so that's a really interesting question. And then there's a few next steps that we think about. We won't address all of them ourselves, but I think what the field needs to be doing is really come up with better definitions, right? We need to really work on what do we mean by all of the different constructs and labels that we have around. Then what we try to do, and I hope the German Research Foundation is allowing us to, is to apply this more broadly. So this was only based on a few thousand items. Out there, there's probably a few 10,000 items. There's also items in all sorts of different fields. It's not just personality psychology that's producing items. There's also people in management or in the clinical domain that are producing items. All of this could be put into the same semantic space, and then can be used to find out where they have commonalities, try to consolidate the space, etc. And then what's also really interesting, which we really didn't dare to go into because it's probably a whole new large-scale project, is use the item-based information to actually produce better scales, right? So in our project, we took the scales for granted, right? And that's probably the first mistake, because some of these problems, they exist because, for instance, scales reuse items, right? Which we may not want to do, at least not to the extent that it's happening out there in the field of personality psychology. So I think there's a whole entire agenda to try and use this approach for scale development, so that these problems are solved at the root. And with that, thank you so much. Yeah, thank you.
Questions?
Very, very interesting approach, and I think it was extremely needed. I have a few questions. Some of them are more broader, some of them are specific. One specific question I have is that the Jingle-Jangle fallacies, in the way you detected them, there is no guarantee of transitivity. So A can have a jingle fallacy with B, and B a jingle fallacy with C without any
I think that's possible, right? Especially because we use this hard cutoff, right? So then it could be that in some other one it's just below it, and some other one it's just above it. So yeah, I think that's not it's not a given. Yeah.
So thinking we're going to kind of similar problems, one possibility to handle those, maybe similar to what we did eventually, is to represent them as a network. You need to have kind of a jingliness and then cluster on the network, and that will give you the jingle groups.
Yeah. Maybe I have to think about it. I don't know. Maybe my intuition tells me that it's not that won't work that easily, but I have to think through it.
Regarding the broader aspects, we were discussing, because I've been studying for shapes in a specific way for mind. And one thing that your approach, the way you presented doesn't seem to consider fully, is that the example that you had hierarchical structures, and that, for example, borderline is region, etc., are phases of your shapes, which is somehow, let's say, a general name for what's common among several things. So this overlaps, even in like having the same magnitude scale for shapes and orders is not necessarily a problem if they are considered as broader than our specification.
Yeah, I agree. So I think that's not something we consider. Sometimes wonder how useful that actually is to be doing in such a hierarchical fashion, but nevertheless, still you would want to, even if you have a hierarchical system, right? You would want to be to have sort of a maximal scale label alignment, right? Which, right? I mean, that should be a given, irrespective of what kind of system you have, right? And here in this case, we always work with the lower levels, right? So we wouldn't take the scale for a facet of extroversion, and we call it extroversion, unless the inventory would give the name extroversion, right? So in all systems, I believe you do want maximal scale in alignment, right? So in that sense, I think this could be really orthogonal. I mean, it's relevant, of course, for our labeling approach because that's something we're considering. In principle, obviously, you want to go on and now, based on the labels that we identify, come up with clusters and clusters and clusters of those. Right? It's also the case that basically we're using an hierarchical clustering algorithm, so there is always clusters, we need the clusters that we identify. So you could go there as well. So, yeah, so I wonder if really the sort of the tree-like structure that personality ecology sometimes adopts is really incompatible with this approach. I think it is, and I think the Jingle-Jangle problem is just the same for a tree-like structure than just a lot of tree-like structure. What do you think?
Think about it. I think what I think is that this is kind of an automatic approach that takes very good candidates, and then, for example, you may decide that this is not a problem because this is an umbrella term for these many things, and so, okay, I know that there is an overlap, I won't change that. I will change something else because then you may have problems even in the hierarchical structure you shouldn't have.
I think you need to take into account that really always two things need to be true. Right? So two things need to be true is that we have similar scales that you would have in the facets of extroversion. Right? They would all be fairly similar. For them to be identified as as a fallacy, right? The labels would have to be really different. Right? So it's not just sufficient that two scales are similar for a fallacy to be different. That's fine. Similar, we can have as many similar scales as we want. We just need to make sure that we also give them sufficiently similar labels. And then it's totally fine. That's also why I say that with the right kind of vocabulary, this can all be solved. Right? Because then every similar scale just gets a sufficiently similar label that has the same kind of relationships between all of the other labels, right? Space. Right? So this is not per se a problem. That's also why I say is that they treat with the facets. That's not a problem. It's only a problem when the 10 facets of extroversion, 6 facets of extroversion, they all they receive names that are too similar.
Maybe it's because personality psychologists are very great at finding names. Conscientiousness is an awful name for something. Nobody uses it.
Yeah.
Psychology in general.
And it has a lot to do with that, right? But it's crucial, right? Because then when you do a search on Web of Science, right, Google Scholar, right, you will find the papers and use the charts that you know. You won't find the other papers. And even if you do find them, you have this big uncertainty of whether you can generalize your insights or not, right, from these other ones. So naming is exactly what we need to be investing more into.
Well, my question was about the hierarchy too, but your answer actually explained me another question. In terms of perspective, how do you think that you can transition the taxonomy from where it is now? For example, DeFi is a very solid traditional naming things like conscientiousness and example. And if you apply your method, then you have to switch and try somehow the literature. How can people, if there are humans that use this taxonomy, can actually use your method? That's completely wrong.
Yeah.
How can you guide things in that direction?
It really depends on what that direction is.
Yeah.
So, but I think one thing that, as an outsider, I believe that we should probably abandon a strong belief in these like strong taxonomic systems, right? I mean, there's also the big 6, there's also the big 7, and it really depends on what kind of items you use, what you find as a solution. I spent a lot of my projects about cluster analysis and try to go bottom up, and it always depends on what combination of items you start with, right? And also then for what solution you decide. There's no way to ever identify the perfect solution, right? In terms of moving things together. So I think the first thing that's very useful is to think of this as a more of a continuous space. Maybe with some lumps in them, where there's some things that are just a little bit more similar than other things, right? So that's one thing, and then I think what we can also do is just provide easy tools, right? So there's already a project by Rosenbusch. I don't know if you've seen it. They at some point made the effort of collecting a lot of scales. They used LSA, which unfortunately doesn't work so well for these kind of approaches, but they use this, and then they make the tool available. There's not a shiny out that you can go to and find out what scale similarities. Now with this one, you can do this all at the level of the item. You can have a web tool where you can understand all of the relationships between all of the items. You can understand the relationship between existing items and new items that you come up with, right? And so on and so on. And then, yeah, so I don't know, this probably makes it more complicated, right? But it's also, I think, more true to the nature of the problem, right?
Because the example of consciousness is perfect. We know that it's a bad act from a certain perspective, but it's consciousness too. Like this case that we did, and consciousness actually is not consciousness. But we have to add it because it's the labor of the trait. But in your perspective, this would make things.
There's another interesting idea, and that is to, so we have this group in the Planck Institute. They're interested in units and machines. And one concept that I think really fascinating that they talk about is the idea that language models will allow us to communicate in a less compressed way. So instead of using individual words to communicate the content on the scale, right? Another thing we could do in the future is just communicate the vector that represents the meaning of that scale, right? And then everyone in the future, you can do this already now, right? You can just sort of take your findings with your scale, right, and compare it to the other findings of that scale by evaluating the similarity of the scales facing back.
To see whether or not I understood. And with your embeddings, is it already possible that this number of scores on the subject that have a representation of that subject in mathematical measures?
So
without in discarding all the thing of the label, all the care. You want to represent the person, and you use a multi-dimensional space to represent that person just using the items. And then you use that multi-dimensional representation to do some external validation. So you see, say, the perfect match for, say, job prediction. Use that multi-dimensional representation to predict what's best for the job of the other. Does it make sense?
Yeah, that would work. I mean, we'll have to think about how exactly to implement it, but a stupid way would probably just to weight the vectors, whether it's constants that they gave, right? So then you have more of the items in there with the higher responses, right? Or you do that with distance 1.5, and then you go to that, and you average all the items in here, and if people, you will have the people in that semantic space and produce these vectors at rates.
But that, in a way, could help you in weighting what is mattering in the world. This would be not in a theoretical space, but maybe it's just a narrative that we use to make sense.
No, I like that. And I think it has to do with sort of my theoretical perspective of sort of judgments that people at least us, right? Because I believe that we've neglected the fact that we have these different engines in our minds that are really good at picking up semantics. At some point, or at some point, I like to go to parties, and I also like to say that I like to go to festivals, right? But we also have a drive to be consistent, right? So when we give answers on personality inventories, we may just use our semantic understanding of personality to give parts of the answers in our data, right? And I think what we need to do now is maybe separate sort of the semantic and the behavioral component from each other, right? And this will require us going again more into the world and trying to also ask us what is it actually that we want to capture, right? Is personality thought of as an interpretation of personality in people's minds, or is it meant to capture sort of systematic behavioral tendencies out there in the world? And this may actually also allow us to, we can do what you suggested. We might also be able to use semantics not to partially, but to separate these two parts from each other, right? So we can take behavioral correlations and subtract what we expect based on the language model, and that may give us a sense of the correlations between behaviors that are there, not because of our intuitive understanding of personality, but because these are actually things that happen out there in the world. And the problem is, these two are often fairly in alignment, because what we know semantically is a representation of what's in the world. Anyway.
I was wondering, sometimes when working with word embeddings, there's the problem of antonyms. So two words that have opposite value end up being similar, good, bad, or left, right. Do you think that this could create some problems in your framework?
Yeah, potentially, yes. However, I think in our particular case, because we work with a fine-tuned model, less so, right? It's really to fine-tune the model to capture these empirical relationships. And also, I think I forgot to say this, we train the model to predict the absolute correlation between items. So we don't care at all about direction, we just want to know how related are these two items, irrespective of the polarity of the item. And by fine-tuning it on the real correlations, we'll just pick up on sort of antonyms actually being the same thing in personality, because that's personality what you typically want to do, because you have these negation items or the antonym items that are meant to tap into exactly the same thing as the original without an antonym or not negation item. So here we train the language model to basically just disregard this, right, and assign the same way. Although it might still not be perfect. On the other hand, even the off-the-shelf models, they tend to show this behavior. So even if you, I like to go to parties and I don't like to go to parties, is typically assigned a relatively high similarity score.
No. How do you analysis with time? Or similarities or contrast between different items and so on. If you look at the scales of concept that you are comparing, come from different social background of the people that created them. So the words have different meanings for those that created them. And these may be found if you add some context to the input of the LLM. So it's not my field.
Yeah. So no, I think that there might be some triggers, right? And that's I think one of the big challenges here that we don't have exactly the same semantic system up there, and hence we may not select with the same names to things, etc. In fact, interestingly, this very project started because I was seeing a talk of someone doing intercultural work in personality. So she's going around the world and tries to validate the big five in Asia and in Africa and in South America. Right? And then I figured it's like, I mean, this is great, but how do you make sure that the translations are actually good? Right? Maybe just this, even if it's a good translation, it doesn't mean exactly the same thing in another language. Right? And that's a massive change. Right? For sciences that operate with language as much as psychology does. Right? Yeah, and in this case, this may also to some extent be true. I mean, those people in management of the next scales about human behavior and personality, they may phrase items and labels very differently than personality psychologists do. Unfortunately, I have no information. I mean, we only go to this item database, and this is a database that quite a bit of time ago, one of the leading figures in personality psychology just
But you may try to see what happens when you embeddings from, let's say, religion, constructs, or whatever, and the transformations. Some text from the manuscript of the country as additional additional information much secret and see if that change keeps the meaning of the I don't know.
Yes.
Or try to fine tune the model, the language, and culture, and then extract from that from the descriptions.
Yeah, so that was the original idea that we had. So I used a multilingual model, one of the first multilingual models that existed, the multilingual universal sentence encoder, and to see whether that could actually predict the differences that you see in behavior as evidence for semantic components of the difference in the cultures. The problem is that I think the solution that you suggest, I think points to this is that it's multilingual models that are bad, they take different perspectives, and then producing models that are language specific is tricky because then in these language and cultures, you don't have the same data available than you have in the others. Yeah. And lots of people have to use Wikipedia, for instance, but that's also not fully comparable because it might be a different group of people who work with Wikipedia, it might be a different set of topics reflected in Wikipedia, etc. It's actually kind of a really amazingly complicated but also fascinating problem of translation of semantics between languages. We tried this, I don't know if you know the Fastnext project. It's one of the latest sort of version models. They make available about 170 different embedding models in 170 different languages, mainly trained on Wikipedia. And we try to use that to learn something about cultural differences and risk, and the understanding of risk. And then it was really difficult, really messy. How do you know that the word risk in English is the same as together, or the word danger in English is the same as the word defy in German? It's extremely challenging. Yeah, but what we have learned is that these model language models are really not the solution because they require everything in English and that's American bias, unfortunately.
So maybe this is the same thing that So, let's say, for example, now there are all these artificial humans for video. And we have artificial humans for video games. So when you take the character for video games, you don't describe all the lines of the dialogue. And probably, I don't know if they use like D&D characteristics, like intelligence or the big five or anything. Maybe they give examples of behavior, and then they put in the large language model, and then they have the behavior. So that is maybe some kind of bottom-up approach, like using importantly the text of the person producer to predict their future behavior, but to remove the need for any kind of construct, right? Because if you can predict people behavior and previous behavior, personal behavior, I don't know that many of these concepts would be created.
I'm totally with you. I believe that this sort of exploratory approach in psychology, where we come up with theoretical constructs and then build some kind of functions of it relating the constructs to one another, I think has failed us a little bit. At least I think we've relied on it too much. Right? There's these kinds of problems here. There's also other problems where we just see that stuff doesn't generalize, stuff can't be used to predict stuff, and that in my other life I do decision-making research. Right? Risk is a big construct in psychology, in economics, and philosophy. There's 50 different ways to measure risk. Right? There was a large study that was done in Basel and in Berlin. None of these measures correlate well. And it's the same in other domains as well. And I think this idea of measuring latent stuff and then using that latent stuff to predict something may actually not be useful. I think more of an input output. Take whatever we know about people and then try to extrapolate of what maybe the next action of the person is. It's probably the more fruitful approach. But one where we give up on constructs and we give up on identifying functions. We just use a large neural network, feed it with whatever we know about an agent, right? And then trying to predict the next action. Maybe in exactly the similar way we train the neural networks now. So the next action prediction.
But in that case, you can try to do something like sampling, let's say, if you have a big model of, and then we can set idea what will be the next behavior of the human. So that may give you information on what you have to ask the human to predict the next movement. So that can create, say, a space of things that you can use at least for that LLM to predict its next behavior. So that would be like the neural network version of the construct, because it will minimize, you will probably have a space where if you cover all the dimensions, you will be able to predict exactly the next neural network output. Otherwise, if you don't have the dimension, the neural network will be complete, considering on the training, because this train of billions of people, so it still doesn't cover the dimension. So you may need to get information from that. But you can use this to do like interesting interviews with the person.
Yeah, sure. Yeah. Yeah, sure. But yeah, but on the other hand, I think these models are amazing at that. Right? I mean, we see it in content. Right? So with this idea of fine-tuning in general, I mean, we use it here. But I think the AI spheres realize that it's actually not as necessary. It's only necessary if you want to have a really specific application and you want to apply it at scale. But the majority of problems can really be solved without by just content. Right? So, and that tells us that if you have a really good foundation model about, say, human behavior, not that we're close to it, right? But you have a really good foundation model, then you may only need to provide very brief information about that individual for the prompt to be able to make.
The point is what will be the feature of that prompt.
Yeah, sure, yeah.
Because usually you prompt with random things, it will get that prompt.
Yeah, that's an interesting question. Yeah, and I agree. I think obviously those features, they may constitute obviously best possible personality inventory. Yeah, I like that idea. Yeah.
wondering, the IBIP is the IBIP is the most organized and targeted thing we have in personality. Everything else is just scales that have been created independently by different groups of authors. And the IBIP, the sentences are all almost the same length, full of the same stem, whereas other skills. And do you see how this approach could be extended beyond the IBIP to different types of skills?
Yeah, and that can obviously present challenges, right? Although in the training of the model, we don't just use IBIP, right? I mean, we have these open databases, but they're very similar in terms of. So I think we really wanted to extend some of this model, and we have to train a new model. Fortunately, there's this other team who's trying to do this. They have used a larger set of training data, more diverse. They also try to predict the directionality. Problem is this is still in the making, and they don't share it publicly. It's one of the authors, also it's only half academia. The other half is a professional psychometrician who is selling those services. So I'm not sure if they will make their model publicly. But it will be relatively simple to actually replicate their approach, just to spend more time on just gathering data sets and training it with a larger variety. And maybe also training a larger model, because this is relatively small. But then I'm pretty confident that we could probably build a fairly generalizable language model that generalizes not just what the type inventories and do stuff. In fact, in the grant that I wrote, it's part of the agenda to try to do something.
I was wondering, so the problem of taxonomies is that they're always not translated.
Yeah,
for translated. And for example, we have these big consensus papers on semantic memory that kind of show that there are a lack of consensus on anything related to semantic memory. So what I was wondering is how much can you push this to other fields or other topics of investigation? This is that one could say that personality is one of those areas where there is a certain degree of overlap with the language that we use as scientists and the language that the layman person uses. And these might make it kind of an easy model for a language model to work, because in language model there are people talking about other people, talking about, even if it's not in technical terms, the personality of other people. So do you think that we can push this to other taxonomies?
I think we can, but probably with some loss, right? That's why I said earlier, we did this in personality psychology, not because we think it's particularly problematic, but because it's particularly easy. Because all of the items and instruments and other things, they're so well portioned and homogeneous in their structure and everything that it makes it really easy. And everything else that doesn't have that character will probably mean that we can predict empirical patterns with less accuracy than we can here. That said, I think a lot of other assessments in psychology are also language-based, right? And even if not, we could potentially translate it into language, right? So one important part that is language is the instructions of tasks, right? So that's also what I wrote into that grant, that we could out there and actually just try to grab all of the different instructions across psychology and then try to work with those. There's also an idea of sort of using an entirely different approach than this one. That's a little bit more similar to what Marcel presented 2 weeks ago, where we can use more of a predictive approach plus some interpretability work in order to understand the relationships between tasks. So yeah, I think there's ways to generalize, but it will require sort of a bit more creativity to make it work as well as it works here.
Question? So the utopia model early afternoon.
Yeah.
So in case you want to go a bit more willing to stay more, we will also have some reads later. You are welcome to join. Tell me. And thank you again. And people are